All right, ladies and gentlemen, today we're going to talk about the simulation that we're going to work on this week, and this is another gizmo. And I know some of you guys don't like it, but I'm going to try and help you with this. Now, in classroom, if you go to your classroom, and I'm coming to you guys, and you should see classwork, and Unit 3, you should see simulation periodic table, which is going to be periodic trends. Go ahead and open that up, and you're going to get this gizmo right here. Then you're going to go to the gizmos and open that up, and I'll put the link into the classroom, and you're going to see this picture. Now, what I'm going to do is pause and let you guys get both screens up. You may have to go back and forth, or you can do it side by side, depending upon if you have your phone or if you have your Chromebook. But I'll give you a few minutes. I'm going to pause right now. All right, so hopefully you're back. You can unpause yourself. And now we're going to go. So what we have, we're going to look at the periodic trends. First go through the prior knowledge, and then we'll do the warm-up, and then we're going to explain how to do this gizmo. So prior knowledge. You got two images on the right, A and B, and the magnets are virtually the same. Which one would be the hard take? And you got this paper clip that's attached through a book. This book's thicker in A, B, it's not so thick. Which paper clip, A or B, is easier to remove? Or which one would be harder to remove? Would A be harder or B? In actuality, it would be B. That one's the hardest to remove, because the actual paper clip is closer to the magnet. The farther away the paper clip is, the easier it is for it to be removed. And therefore, which one will be more likely to attract paper clips? A or B? If you say B, you are correct, because it's looking at the distance between the magnet and the paper clip. So you can attract more paper clips if the book is thinner than a thick book. So this is like padding, or what we call shielding. It's shielding the magnetic field from the paper clips. This one doesn't shield as much. So the next question is, what's the relationship between the thickness of the book and the ability for the magnet to hold on and attract paper clips? Thinner the book, more paper clips. The magnet, whoops, I can't type. The magnets can attract. And that's the answer to number 3. All right. So now let's look at the gizmo. Click over here. When you open this up, you got Explore, you got Explore tab, and you got Trends tab. We're going to go to the Explore tab first. You got the tools, screenshot. Take a screenshot of the screen that you're looking at. You can close it off. Whoops, go back to tools, arrows, and we can activate arrows to figure out what it is. There's your help, and there's the sound. We can turn the sound off if that drives you nuts. Then we have, on this, we have a sample of the periodic table. This is the period or the row that the elements are located on. This row was the first row. We have hydrogen and helium. This is the first family or the first column, or sometimes by group. So the columns have various names. You got to be aware of the different names that these things can have. So this is hydrogen going down that first column: lithium, sodium, potassium, rubidium, cesium, and francium. And so we have this. Again, this also takes a screenshot, the little camera. There we go. And we have this button here that shows a ruler. Now we have a little ruler here, and this is going to give us the length between these two dots. And if we want to show the ion, there's the ion, and it's a very small ion. And so we have these abilities to figure out what we have. So this is, again, this is the atomic radius. We have an ionization energy and electron affinity. And we're going to be working with all three of these trends in this simulation. So go to the warm-up. So, you know, the closer to the electron is to the nucleus of the atom, the harder it is to remove it, and more likely to attract other electrons. And there is some limitations to how this attracts electrons, and we'll talk about that closer in chapter 4. So the atomic radius is the size of the electron cloud, which is true. So this is just a representation of the electron cloud, and we're just saying this is the farthest away that electron can exist away from the nucleus. Now we're going to take this, it says drag one end, so drag this end over. You see it turn yellow, stop. Now we attach that part of the ruler to the nucleus of the atom. We're going to take the other part and bring it closer to that electron. So now you notice this changes. We have a length of 53 picometers. So the first question, what is the radius of hydrogen? And we're going to say 53 pm, which is picometers. I'll bring this down so we can see it. There we go, 53 picometers. Now, on the bottom of this, you notice what picometers mean. 1/20th of a meter. And to put that into scientific notation, 1 picometer is equal to 1 times 10 raised to the minus 12 meters. So that's another way to say it. So on the warm-up, it says on the right side, hit lithium. So we turn to lithium, and the atom changes from hydrogen to lithium. And then we're going to move this to the next electron. Make sure, there we go. Now it says, hey, save radius. If I'm off, the radius is not going to let me save it. Even if I move it there, it's not going to let me save it. So I'm going to put there, it says save radius. So I'm going to save the radius. And so now it's saved, it's 167 picometers. So answer to number 2 is 167 picometers. I'll move this down here so you can see it. And I'll come back to hydrogen. I'll move this back so we can say the radius. You notice that it's populating these atoms. If I come over here to helium, I can say the radius on here, and it's a little bit lower. It's 31. So we could take a look at trends of all of these elements in the periodic table, and that's what you're going to do. So this is activity A is atomic radius, and you need to fill all these tables out. And then we're going to add and remove electrons, and that's ionization energy. So if we go to ionization energy, it's going to change a little bit. And we're just going to move this over until we can move an electron, and it gives us the electron ionization energy. And we can reset, and we go to hydrogen and move it over, and you notice that it loses an electron farther away from helium. And now we got the ionization energies listed here. Next is electron affinity. How much will it pick up an electron? And hydrogen can pick up an electron. And this amount, minus 73, is the amount of energy it will give up once it absorbs an electron. And that's what this is going through. And here's activity C, periodic trends. And that is all I want you to do. Now make sure not only do you answer this, but go to the bottom here, and you got 5 questions that you need to answer. All right, if you get less than 3 right, you need to redo it. All right, and you need to email me that. Redo it, take a photo, take a screenshot of the corrected gizmo and email it to me so I can get the grade in there properly. All right, ladies and gentlemen, this is it. Thank you, and I will have another video for you.